Hi class, Professor Harrison here. What I'm going to do today in this video is take you through how to do a bond problem. In this particular bond problem, we need to find, first we're going to calculate the present value of the bond. Second, we're going to calculate the cash that is paid upon the bond in the first year. And third, we're going to calculate the interest that is paid upon the bond in the first year, the interest expense. So first of all, we need to do a careful reading of the problem to know what we're trying to get out of it. Borg 9 Incorporated, an entertainment company, is going to issue bonds in the amount of $1 million to fund their next project. The bond offering will pay semi-annual interest at a rate of 6%, and the principal of the bond will be paid off at the end of 7 years. The market interest rate for similarly rated companies and bonds is 6%. So in order to figure out the present value of that bond, or how much cash Borg 9 is going to receive today, there are two pieces to that particular puzzle. The first piece I've drawn here as the interest payments that are going to go out for the company. We need to come up with how much money is that worth today for those interest payments that are going to go out over the next 7 years. The way that we need to figure that out is we take the principal of the bond that is to be paid times the rate, this happens to be the coupon rate, which is 6%, times time, and it's for 1/2 of the year. So we have principal times rate times time. That amount is going to be $30,000. So every 6 months, the company is going to pay out $30,000. In the future, at the end of this period of time, there's no additional payment that we're going to calculate at this point in time, so our future value is currently 0 for this part of the problem. Our interest rate is going to be the market rate. The market rate is the rate of similar bonds of similar companies with similar maturities. In our example here, the market rate and the coupon rate happen to be the same. That is 6%. But we have to recall that this is semi-annual interest, not annual interest. This is an annual rate. So we have to divide by 2 to get our semi-annual interest rate of 3%. The number of periods that we're going to be paying out corresponds to the number of years. But since we're making 2 payments per year, we're going to make a total of 14 payments. Over that period of time, we have our $30,000, and what we need to look up in our table is a present value annuity factor. Looking at our table, we go to the table that says the present value of an ordinary annuity. We run our finger over to our interest rate, 3%, and we run our finger down to 14 periods, which gives us a present value annuity factor of 11.29607. We multiply our payment, $30,000 for every 6 months, times our present value annuity factor, and we get a result of $338,882, and I'm going to just round off the cents. That's 1/2 of the problem. The second half of the problem, we need to find out what is the present value of this principal payment. The principal payment we know is going to be $1 million. That is a future value, that $1 million that the company is going to have to repay on these particular bonds. As you can see by my graph here, there's no payment going on in this half of the equation, and we're solving for present value. Our interest rate is going to be the same as it was from our previous part of this problem, and that is going to be our market rate, 6%, paid semi-annually, divided by 2, or 3%. Number of periods, 7 years, times 2, because we're paying twice per year. So it's compounding twice per year, 14 periods. At this stage, we're going to take our $1 million, our future value, we're going to multiply it by a present value interest factor, different from the annuity factor. This leads us to a different table, and our table in this one is the present value of a single amount. We're merely shifting this $1 million back in time. We run our finger over to our interest rate of 3% and run our finger down to 14 periods. There we find a present value interest factor of 0.66112. 1 million times the present value annuity factor of 0.66112 gives 661,120. The combination of having to pay off that future value and the interest payments along the way, that is the present value of what this bond is worth today. So when I add those two together, I get a total of $1,002,002. Then you ask yourself, why the $2? And it has to do with the amount of digits that we have available to us in our chart, which creates a rounding error. So essentially what we get is when the market rate is equal to the coupon rate, that is the present value of the bond. So I'm just going to go ahead and note, since I know that to be the true present value of the bond, and I realize that my charts are giving me a rounding error, I'm going to use my $1 million. The second half of this particular problem has me figure out what is going to be my interest expense. My beginning value of the bond is what I calculated as my present value. Notice that I have taken off the rounding error. $1 million. The semi-annual interest payment. This is how much cash is going out the door, and this is based solely upon the coupon rate. That is built into the contract of the bond. That is 6% per year, and we multiply that by a half year. So this is going to be 3% of the total. I know that in each semi-annual period, $30,000 is going to go out in cash. That's what's in my bond contract. My interest expense is based upon the present value of my bond times the market interest rate. The market interest rate in this example happens to be the exact same. I multiply it by its time, and still it's 3%. My interest expense is also going to be $30,000. Since there's no difference between the interest expense that's going to be on my income statement, the cash that goes out the door from off of my balance sheet, there's no change in the ending value of my bond. Now realize that this is for the first semi-annual interest paid. So this is for the first 6 months. The second 6 months, I copy down what my ending value is at the end of that 6 months, and it becomes the beginning value for my second 6 months. I multiply that. I know that my $30,000 cash is going to go out the door. I take my beginning value, I multiply it by my market interest rate adjusted for time, and I get my ending value. So to answer the question, how much cash went out the door in this example in the first year, that is my semi-annual interest. $60,000 went out the door in cash payments to the bondholders for taking the risk of buying this bond. My interest expense shows up on my income statement, and that also, because the market rate was equal to the coupon rate, is $60,000. I want to thank you for taking the time to watch this video, and I hope that it was helpful.